screen and we're going to look at a problem here. All right, so we're asked to multiply a couple matrices. And this can get a little tricky. So the first one we're asked to do is A times B. So first of all, we have to make sure we can multiply these. So let's look at their sizes or their dimension. And this one is a 1, 2, 3, 4 by 1, it looks like. So we have a 4 by 1, and then B is a 1 by 4. 1 by 4. And in order to realize whether we can multiply them, we want to look at these two numbers right here. So it's A times B, so we're looking at these two. If they're the same, then yes, we can multiply them. Then I look at the two outside, and that's the size matrix we're going to get out of it. So this is going to be a 4 by 4, so that's a pretty good size matrix there. So let's go ahead and do that. Let's do our multiplication of these two matrices. So I'm going to go ahead and write, here's my A, which is 1/2, 0, 5, and 9, times the B matrix, which is 2, 4, 6, and 8. And we're going to get a 4 by 4 out of it. And I'm going to make this pretty big because I'm going to write out what we're doing. So remember, we have positions here. So for example, this is A1, 1. This would be A2, 1, A3, 1, A4, 1. So it's rows, remember, rows by columns is the size. And then this would be A1, 1, A1, 2, A1, 3, and A1, 4. So they're all in the first row, first column, second column, third column, fourth column. Okay, so I want to find, this is a 4 by 4, so we're going to have A1, 1. We'll have A1, 2, A1, 3, A1, 4. And then this will be second row, first column, and second row, second column, and so on. So we're going to fill these in. And then we'll talk about why. Third row, first column, third row, second column. And again, these are just positions of this matrix we're going to get out of it. I probably should have called this C or a different matrix, but anyway, I've used A here. So this is A3, 4, and then we're in the fourth row, first column, fourth row, second column, fourth row, third column, and this is the fourth row, fourth column. And you know, our diagonals are all the same. You know, they're all 11, 22, 3, 3, 4, 4. Anyway, that's our main diagonal there. So let's look at what we've got going on here. So I need to find out these positions. So A1, 1, how do I find that one? And again, this takes quite a bit of time. We've got 16 different values we have to find. So that means I use row 1, column 1. So row 1, column 1, I'm going to multiply these and then add them. So 1/2 times 2, well, that's 1. Okay. And there's really nothing else. That's the only thing in that first row, and that's the only thing in that first column. All right. So let's look at the next one. So that would be my A1, 1. That would go here. And then A1, 2. That would go here. All right, and we'll fill these in here as well. So that would be first row, second column, and I'm going to multiply those two together. So 1/2 times 4, well, that's 2. And then A1, 3. So that's going to be this position. So that's going to be first row, third column, first row, third column. You see that's where it is. 1/2 times 6, well, that's 3. And then first row, fourth column, first row, fourth column, and that's going to be 4. Okay, so let me go ahead and fill those in here. So that's going to be 1, 2, 3, 4. All right, now we're going to work on the next row. And you don't have to do these really in any specific order. Just keep straight what you're doing. 8, 2, 2. So we're going to look for these positions as well. 2, 3, 8, 2, 4 equals. All right, so now I'm going to start with row 2 of my first matrix and multiply it times row 1 of the second matrix. So, okay, so row 2, column 1. Sorry, I think I said row there. Row 2, column 1. Well, there's only one number in each one, which really makes it nice. These can get quite tedious when you have more than one there, and we'll look at that. All right, and then second row, second column, that's 0. And, 0 times all of these is going to be 0. So again, that was not too bad here. All right, and then now we're going to look at row 3 of the first matrix and column 1, and then row 3, column 2, and so on, like we've been doing. 4, and then equals. All right, so now this is going to be 5. There's my row 3, column 1. 5 times 2 is 10. 5 times 4 is 20. 5 times 6 is 30. And then 5 times 8 is 40. And that'll be our next row 3. 10, 20, 30, and 40. They made these numbers pretty nice for us here. Let me see if I can scroll down this or scroll back up a little bit. There we go. And then let's look at row 4, column 1. Row 4, column 1, that's going to be 18. This is row 4, column 2. That's going to be 9 times 4, which is 36. And we got row 4, column 3. So row 4 in the first one, column 3, 9 times 6. 4, and then a 4, 4, which would be 9 times 8, which is 72. Okay. So let's look at what we're, oh, what am I doing here? Let's go ahead and plug these in. I was getting ready to go on. 36, and then 4, and 72. There. And that would be the matrix A times B. Then the next one, let me scroll up, is going to be B times A. So first of all, we have to see if we can do it. So can we do B times A? And we know B is a 1 by 4. Oh, 1 by 4, and A is a 4 by 1. By 1. And we look at the two inside here. If they're the same, yes, I can do B times A. And I'm going to get a 1 by 1, which is one number. So this one is going to be a 1 by 1. So B times A is going to be a 1 by 1 matrix, whatever that one is. So it's going to be pretty small. We're going to have one row, 1 column. That's all it's going to be. That's a 1 by 1 row, 1 column. And you might be like, how is that going to happen with these matrices here? Except it's going to be the other way around. It'll be B, which is 2, 4, 6, 8, times A, which is 1/2, 0, 5, and 9. Okay, so we'll multiply these. So row 1 by column 2. Now this is where it gets a little tricky, but the same print. I'm going to do row 1 times column 1, except I have more than one number here. So row 1 times column 1, that's going to be 2 times 1/2, which is 1, plus 4 times 0, which is 0, plus 6 times 5, which is 30, plus 6 times 9, which is 72. So again, look at what we're doing here. I'm going to do row 1, column 1, which is 2 times 1/2, which is 1. Okay, then I'm going to do 4 times 0, which is 0. And we're going to add these. 6 times 5, which is 30, and then 8 times 9, which is 72. And then we're going to add these together, which is going to be 1 times 30, which is 31. 31 plus 72. And then what is 31 plus 72? It's 103. And that is going to be my 1 by 1 matrix for B times A. Okay, so here is that 4 by 4. Luckily, they gave us some zeros in there, made it a lot easier. And then here is my 1 by 1 matrix. So hopefully that's helpful there for that particular question. If you have any more questions, please don't hesitate to ask, and I'll be happy to help.